right? So the memory representation is said to be two types. One is sequential and the other one is linked. So sequential, this is how the values will be stored under the memory. As I told you, there are ways how it will be represented. So this is left subtree of b and this is right subtree of b. And say suppose here there should be a possible element but the element is not there, and here also the element is not there. So these elements places will be considered and it will be taken as 0 in the sequential memory part, right? So the first memory location, that is a, that is the parent, and followed by left subtree, that is b, and it will be stored as b, and right subtree, that is c. And then this level, then it is coming to the third level, that is said to be b. B ka left and right, so that it will be started initially. So there is no value, there is no node actually, so it is stored and it is just stored 0 to to mention that element is null. And the second thing again it is 0 to mention this element is null, followed by the next values are d and e, that is all the left and right subtree for the node c. So this is how it will be maintained in sequentially, right? Right, how it will be mentioned in linked list, this is very important, how it will be mentioned in linked list. As I told you initially, the linked list is said to be two parts. One is node, and the node consists of two parts. One is what? The information, and the other one is link. So here, instead of single linked list, we have to use double linked list. Double linked list means there are two parts. One is left side address and this one is said to be the right side address. There will be two links in the node. So at the center part is said to be the information, and left hand side is said to be the left address for the node, and right address is said to be the right hand side node address. So this it will be connected individually, right? So this it will be used, the double linked list is used to store the tree data structure, right? See here the simple explanation, it's given like a, b and c. So a will be connected to b and a will be connected to c with two different places. Like, see here, this is the starting node, it is connected to a, right? Connected to A, and A is having a left subtree and a right subtree, that is memory address 4 and 5. So whenever it starts execute, this is storage. This is how it is stored in the memory. Now I am talking about execution part, how it will execute from the memory. So it will go to the second memory location, that is A. It will be retrieved A, and followed by memory location, that is left memory location, it is 4. Always it will complete the left subtree first, right? Left subtree first, and it will come to the right hand side. So as per that, first it will go to the node number 4. So node number 4 may b is given, and followed by b, because b is the terminal node, so there won't be any further addresses, so 0 0 will be given, right? So this left part is done. That means what? This a ka left part is completely done. So directly it is going to right hand side of a. When a ka left hand side is completely done, it will directly go to right hand side of the a. Right hand side of the a is mentioned as 5, so it will come to the fifth memory location, that is c, right? In c, that is a terminal node again, so there are only zeros maintained in this particular memory locations of left and right. Is it clear? The memory representation of linked list is very important. It's a 4-mark question, right? Either they may ask linked memory representation or they may ask in general. So if they are asking in general, you have to write both in a simpler way, simple example. And if they are asking, if they are specifying only about the link, then you have to explain little more detail. So the question, it will be what is linked list and explain the memory representation of linked list with an example. So you need to take a example. Again, I am repeating example. You take a simple example and everything. It should be predefined initially only. Prepare yourself the memory address and the values what you are going to write it, because at the moment if you are writing any random memory addresses, random values, then definitely you will fall in some trouble. So don't take that risk. Prepare yourself initially only. Right. Next is stack and queue. Before going into stack and queue, I would like to give some example of tree, how to draw the binary tree for expression. This definitely there will be a possible question. So I want to show you E is equals to A plus B whole square multiplied by C divided by F. So always you have to consider the C divided by F will be having a bracket. So you can take this as a simple expression. This type of expression they will give. Listen carefully. This will be a 4-mark question, right? So when they are giving an expression like this, now E is said to be a operand, and this is said to be a operand, and this is said to be your major operator. So you have to start from that major operator. What is that major operator? Right? This is the major operator, that is plus, sorry, equals to. Now here equals to is said to be your major operator. And equal to the left hand side, what is there? Equal to the left hand side is what? Equal to the left hand side is what? E. Right? And equal to the right hand side, if you see here, this is said to be the major expression. In this major expression, I can consider this major operator as star. So star will be the major operator in the right hand side. So I am writing it as star. So if you see star is the major operator, star ka left hand side is A plus B whole square, star ka right hand side is C divided by F. So if you see A plus B whole square, in this A plus B whole square, I can take A plus B whole square, I can take the power, the exponential will be the major operator. So that I can take a major operator here in the node. And for this, the right hand side will be square, right hand side will be the square, and left hand side is said to be A plus B. So A plus B, again if you see, that is said to be expression, so that it can be further subdivided. So the major operator of A plus B is what? Plus. So plus will be the major operator, and for this plus I will be having two another nodes, one is A and the other one is B. So this is my A and this is my B. Right. So you need to draw this as well. The lines you need to connect it. That is very important as well. Now I didn't complete this entire diagram as of now. I just completed a part. Now this right hand side is remaining, that is C divided by F. So out of the C divided by F, I can take the major operator as division, right? So for division, I will be having two nodes, one is C and the other one is F. So this is division, and this is C, and this will be F. Then this will be connected with the lines, right? So this is how you need to draw the binary tree for this particular expression. As I told you, the level numbers and everything, it is important. See, this is how you need to maintain the level numbers. And moreover, I have not used more than two nodes in a particular binary tree. So how many levels? 1, 2, 3, 4, 5 levels are there, right? So 2 to the power 5 minus 1. 2 to the power 5, 32 minus 1, 31. So 31 will be the maximum possible elements in this binary tree, right? Out of that maximum, we are not maximum. We are, is it the tree is visible for you all? Hello.
Yes, sir.
Okay. Right. So likewise, the expression will be asked, and you need to draw this. If, say, suppose in this expression, if this E part is not there, right? Consider this expression. If this E part is not there, they are just given only this. So in that case, don't start from this E. You have to start from this star. Is it clear? So if this is the expression, then don't draw this. You have to start from this particular point. Clear? So it is based on the question you need to write. If you have any doubts, you can ask me now regarding this binary tree drawing, because this is very important. Okay, I think you don't have any doubts. Right. So the remaining part is what stack and queue. So stack is said to be a linear data structure, and the queue is again a linear data structure. Stack, it follows LIFO methodology, that is last in first out methodology. The elements are will arranged in the format like this in array, right? So 11, 12, 43, 24. The elements whichever I wanted to insert into the particular stack, so I need to use the method called push. The name of the method is push. Push is a method to insert an element into the stack. The element, it will be inserted and the top of the stack. So this is said to be the top of the stack. This is said to be the top of the stack, right? Just give me 5-10 minutes more. I will complete this. Then likewise, the elements will be inserted on the top of the stack. So whatever elements, if we wanted to remove, that it will be removed from the top of the stack only. So that name is said to be pop. Pop means what? Removing the element from the top of the stack. Push means inserting an element into the top of the stack. So these are the two operations. So they may ask combined stack and queue for 4 marks. So 2 marks will be given for stack and 2 marks will be given for queue. So in 2 marks, the diagram it carries 1 mark and explanation of stack with the multiple operations, right? And a small example, right? Example with this diagrammatical format. Example with the diagrammatical format, 1 mark, and explanation of stack and with the different types of operations that carries 1 mark. So these things we have to explain it. Same way in queue, the explanation of queue, the explanation of queue will be given for 1 mark, and the diagrams for the operations which will be given for 1 mark, and the types of operation that you have to mention that will be for half mark. Half mark and half mark will be divided, so totally 2 marks will be given, right? So a queue is again a linear data structure. It is example like I can say how we are maintaining a normal queue in uh, movies or in ticket counters, right? So whenever you are getting inside, there will be n number of persons behind you. So when the first person getting a ticket, that person will come out of the queue. So this is the normal procedure. The same procedure we are using in the data structure, right? So the elements it will be maintained in the memory places, right? The element which you wanted to insert, it will be added at the end. That is said to be the rear end. So in the rear end, the data will be added, and in the front end, the data will be removed. So these are the two operations: addition, insertion, and deletion. Right? Insertion will be done at the rear end. Deletion will be done at the front end. Right. So it follows first in, first out method. That is FIFO. Stack follows LIFO. Queue follows FIFO method. First in, first out. The first element which is inserted in the queue, which will be the first element removed. Right. So this is how you have to explain with a small example with the diagram and the explanation. Right, so that's all about this entire chapter is done, data structure. So next class I will keep